There we go. No biggie. All right, so the recurrence relations that relates to annuities. Whoops. That models annuities. And it's the following. All right, so you will put in a certain amount, or you'll have a certain amount in there, and that's called principal. All right, so it's there at the what you've got at the start, and then the next payment that you receive relates to. There'll be some interest that that the annuity investment will receive. So it's on the previous value. And this time, because the investor is receiving money, the value reduces by whatever that payment is. All right, so big R is one plus little r on 100. All right, so that's working out your compound interest on this amount, this value, after end payments. So little r, of course, is our interest rate per compounding period, or payment period, compounding period. And D is the payment that's received. All right. So let's have a look at an example. And I'm going to use an example from your textbook. So it's example 11 on page 330. All right. So we're going to use our recurrence relation for this to work this one out. So in the example it says Reza plans to travel overseas for 6 months. He invests $12,000 in an annuity which earns interest at a rate of 6% per annum, providing with him monthly income of $2,035 for the 6 months. All right, and we're then asked to model using recurrence relation, model that, and then after we've done that, I'm going to add another part. There we go. All right. So let's write our information down that we need. So first of all, we're just told that he invests $12,000. So that's his initial. He's got $12,000 in there. We're then told that it's an interest rate of 6% per annum. in his monthly income, D, $2,035. And we're asked to model that. Okay, so with this it's not clear, but I'm assuming that the interest rate is compounding monthly, but it's not clear in there as to whether it is. So if we do that, we need to go over 12, which is 0.5% per month. Okay, so our big R then would be 1 plus 0.5 over 100, and when you work that out, it becomes this, 1.005. So the recurrence relations then, so the recurrence relations have two parts. They have our principal, V0, which is 12,000, and then the other part is how the value after a certain number of payments relates to the value after the next payment, and the R is this one here. Alright, so whatever the value's worth now, earn a bit of interest on it, then take out $2,035, and then that's what we've got next. All right. All right, so that was example 11. Now I'm going to pull a bit out of example 12. So example 12 uses this. So example 12, part A, would be, so what is the example, is the value after 3 payments. Alright, so 3 payments, what that means is n equals 3, and then we can use our calculator to do that. So where would we go in our calculator to do that? Which one are we going to use? Sequence. Alright, so calc, sequence, and there's 2 tabs, and we want the recursive. Alright, recurrence relation, recursive, both start with R. Little hint for you. Alright, so when we do that, those watching the video, you just have to figure it out. Alright, so AN plus 1 is equal to R times, and R is 1.005 times VN, and we're using AN, so don't forget that's in that drop down menu from very top. And then we're taking out some money, 2,035, and A0, the value to begin with, he put in 12,000 to tide him over. Alright. Then, when we look at that, and we look on our table, for n equals 3, how much have we got left? After 3 months, how much is his?
6,045.
6,045. and 3.3. Now, I've shown this to some people, but not others. So in the table here, it's just got one decimal place. We've got some money, so we need two. If you go and you just click on that value, you notice down the bottom here, gives you more decimal places. All right. So when we look down the bottom, how many cents have we got? 33. Okay. So $6,045.33 is how much Teresa has left. All right. So that's how we would use our recurrence relation, but we can also use our financial solver. So let's have a look at an example where we would use the financial solver. So again, I'm going to use an example from your textbook. Save us writing out a whole bunch of words. Spending time doing that. Page 333. All right, so Joe's investing some money, 200,000, 5% interest per annum, compounding monthly, and then there's three different scenarios here. All right, so initially for part A, going to have a look and says, so we want to be paid monthly payments for 10 years. So in our financial solver, it's our N is the number of payments, and we want monthly ones for 10 years, so there'd be 12 months in the year times 10 years. So Joe's going to get 120 payments. All right, the next thing in our financial solver is we need some interest rate, and in this case the interest rate is 5%. And remember, we don't need to change that. The financial solver does that for us when we tell it some other information later. And that other information is the number of times it compounds per year and the number of payments received per year. So how many times is it compounding in the year? And how many times in the year is he being paid? 12, because he's being paid monthly for 10 years. All right. Got to put money in there. So he puts money in there to present value. So the present value is 200,000 plus or minus? Minus, because that money has come from him. Come from Joe. All right, so he's put it in, so it's minus. All right, the future value. Good question. Future value. Oops. Give me the answer. Or I wanted to. So, future value, you need to be careful and read the questions and interpret what the question is. So he invests that. In the question it says, if he wishes to be paid monthly payments for 10 years. So from that, you would say that that's it. He wants the money for 10 years, payments for 10 years, and then that's it. So if that's the case, then you would say that the future value would be 0. Because it doesn't indicate that anything that he wants anything to happen after that 10 years, just wants payments for 10 years. And so you put the future value then as 0. Alright, so then what are we after? How much are we going to get paid? How much is Joe going to get from that? So that's where we go to our solver, financial solver. So 120 is the number of payments. Interest rate is 5. Present value, negative, because he put it in. The payment at the moment, there's nothing in that. That's what we're going to find out. Future value, going to be worth $0. 12 payments in the year, compounding 12 times in the year. And payment. Click on that, and what do we get? So how much is Joe going to receive each month for those 10 years? $2,121.30. We will get $2,121.30 for 10 years. 31. Thanks, Sam. 31. Correct. Then after that, he's got no money left, and he's going to have to figure out some other way of living. That's the case. All right. So in the next scenario, asks us some other things. So in the next scenario, we've still got the same amount of money that he's put in, but in his next scenario it says if he receives a regular monthly payment of $3,000, how long will it last?
Not that one.
Alright, so N is how many payments it will receive, and so that's what we're trying to figure out here, how many payments there would be. A whole bunch of other stuff doesn't change. The interest rate doesn't change. The number of compounding periods doesn't change. The number of payment periods in the year doesn't change. The amount that he invests to begin with doesn't change. His future value still doesn't change. This time we've got a payment. Payment is $3,000. Positive or negative? Positive, he's getting the money. Right, so you put that 200,000 in and he's getting bits back. So the bits he's getting back, positive. All right, so we just make a couple of changes. So I've just got to change the payment in the financial solver to 3,000. And then if I just go and click on the N, and 78.26, and it asks us to give our answer to the nearest month. So our answer to the nearest month would be 78 months. Okay. All right. Then the third scenario with Joe and his money. Gives us some more information to see. So the third scenario. What interest rate correct to one decimal place would allow Joe to withdraw $2,500 each month for 10 years? So N monthly for 10 years, so that's 120. question asks what interest rate, so that's what we're trying to find out. He's still compounding 12 times in the year, still getting paid 12 times in the year. He's still put in 200,000, and at the end of his 10 years, there's going to be no money left, and we want a payment of 2,500 this time. All right, so we just go and change those things. N120, payment, change that, 2,500. And this time, we go and click on the button next to the interest rate. And when we do that, it says 8.6892246162. And the question asks us to give it to one decimal place. So one decimal place is 8.7%. All right. Okay. Anything about that anyone wants clarifying before we go on? All right, so most of the time with your financial solver, you've got to pay attention to whether things are positive or negative. Okay, so don't forget, always think about, is the money going away from the investor to the investor? Money coming to the investor is positive, money going away from the investor is negative. All right. All right, that's about it. 9E, questions on your work plan. And don't forget, like and subscribe.